So students will multiply polynomials using the rules of exponents and the distributive property, and divide polynomials using the rules of exponents and long and synthetic division. Again, hopefully this will be more review to you. Here we go. A monomial times a monomial. We've done this year. Okay, it's just lots of, and a lot of this is like this. There's a lot of overlap. You can even think of us. We did this when we dealt with imaginary numbers. We dealt with this when we did rules of exponents. Again, the rule is if you have a monomial times a monomial, multiply what you can. 3 will multiply times 4. 3 times 4 is 12. There's no distributive property here. There's no FOIL. There's no plus and minuses. 2x's times 5x's gives you a total of 7x's. 12x is 7. Done. Next step up. Let's go to distributive property again. Negative 3x is being multiplied times both of these things. Negative 3x and 2x gives you a negative 6, and x times x is x squared. Now, if you were adding those two things, you're not. But if you were adding those two things, you would simply worry about the negative 3 and the positive 2. But you are multiplying them, so you have to multiply each piece. Negative 3x times negative 3 would be a positive. 3 times 3 is 9. So negative 6x squared plus 9x. FOIL. And we have done some FOIL, but not a ton of it this year. But I do want to show you, again, how I think of this. FOIL, again, is simply the distributive property. Instead of having a single number out front, like a 2, and you're multiplying 2 by everything, you have two things out front. You're going to distribute the 3x to each of these. Then you're going to distribute the 1 to each of these. And the reason I teach it like the distributive property, because what if you had this problem? 3x squared plus 5x plus 7, and you will have these, times 2x squared plus 3x minus 4. It's hard to FOIL that, because there's more than just a first, outside, inside, last. But if you know that this is distributive property, you're going to take 3x squared, you're going to multiply it by all three things. You're going to take 5x, you're going to multiply it by all three things. You're going to take 7, you're going to multiply it by all three things. There's 9 things to multiply together there. But it's the distributive property. That's all it is. So back to this problem. 3x times 2x gives me 6. X times x is x squared. 3x times 5, the only things you can multiply together there is the 3 and the 5. Leave the x. We're done with 3x. Now distribute 1. 1 times 2x and 1 times 5, I believe would just be 2x and 5. The middle terms we can now add. You have 15 x's plus 2 more x's, which is a total of 17 x's. Again, that is FOIL. Next section, we're actually taking that and going back to this, which is called factoring. Reverse FOIL. Of course, next problem. Led right into it. Distributive property. All three of these things are multiplied by each of these two things. Help me with this, Daniel. X squared. Let's multiply x squared times each of these. X squared times 2x, Daniel. What do you get? 2x cubed. Good. X squared times 3, Daniel, is x squared, because there's no other x over here. You can mark out the x squared. You're done with it. Noah, go on to negative 3x. Help me with it. Negative 3x times each of these. Noah, what do you get? And negative 3x times negative 3 is positive 9x. Good. And the last one, Skyla, distribute the 4 for me. And good. And I'm doing something weird here that you might not have ever seen before. Most of the time you just list those things on out, right? You've got them all just strung out there. You can actually line these up as you go, and you've got all your like terms stacked on top of each other. That way you don't have to search for them. 2x to the third. Negative 3 and negative 6 gives you negative 9x squared. 9 and 8 gives you 17x and minus 12. You don't have to do it like that. You can search for like terms if you'd like to, but that's another way of doing it. Notice this. A squared b plus 5, a squared b minus 5. Caleb Henshaw, do you remember what we called these? The only difference is this. Thank you, conjugates. On your conjugates, you have shortcut. Please use the shortcut, because here the other way is going to be kind of nasty. When you have conjugates, multiply the first, multiply the last. You don't have to FOIL it completely out. Help me with this, Lydia. A squared b times a squared b would be a to the b to the good. The last terms, positive times negative be a negative. 5 times 5 is 25. Any questions? I know I'm kind of flying through these. Hopefully we kind of remember. A plus b squared. Again, the only reason I put this on here is to say it again. To say one more time that you can't just say a squared and b squared. If this were the problem, yes, do a squared, b squared. As soon as you throw that plus or minus sign in here, it makes this completely different problem, much more difficult. A plus b squared is a plus b times a plus b. If you had a plus b to the third power, you have to do a plus b times a plus b times a plus b and do 2 at a time. Okay. A times a is a squared. A times b is ab. B times a is not ba. Let's write that also as ab. Just put them in alphabetical order. That way combining like terms is much easier. And b times b is b squared. And you can combine your abs. And you get a squared plus 1ab plus 1ab is 2ab plus b squared. 3x to the n power plus 5, 3x to the n power minus 5. And like Caleb said, this is conjugates. These are conjugates. And when we're dealing with conjugates, you multiply the first terms, you multiply the last terms, and it's going to be a minus because you have that positive times a negative. But the issue here is we don't have a number there, and that just completely blows people's minds. You know, how in the world are we going to do x to the m times x to the m? Please watch this. If you don't know how to multiply some abstract something, make it real to you. Ask yourself, well, how would I multiply x to the third times x to the third? And we multiply those by adding. So how are we going to multiply x to the m times x to the m? We're going to add m and m. Right? Awesome. So you got 3x to the m, 3x to the m, which is a 9x to the, what's m plus m? 2m. 9x to the 2m power. This is more real to us, like I said, because you got those real nice, neat whole numbers. They're positive. But m and m just makes me hungry. 3x to the m, 3x to the m, 9x to the 2m. Minus positive 5, negative 5 is negative 25. Again, been there, done that. And a lot of this first chapter is review. A lot of overlap. This again is FOIL. Notice you have conjugates. 3 times 3 is 9. Try again. Minus, because you have negative times a positive, root 6 times root 6 is 6. Final answer, 3. When you multiply conjugates containing radicals, you'll always end up with a whole number. When you're multiplying conjugates that have i's in it, you'll always end up with a whole number. Because those radicals are going to cancel each other out. Okay, here we go. Let's divide now. First off, basic division, and we've done this. Again, I want to reiterate the fact that we've done this. This is the basic division. Anytime you see this division symbol, I would much rather see it as a fraction bar. 8x to the fifth divided by 2x squared. Just because you're used to seeing it that way, rewrite it and see if it makes it look a little bit better. Help me with it now, Colby. 8 divided by 2 is 4. And make sure you put the 4 on top. Because I'm seeing some people still, they'll have the 2 on top, the 8 on bottom, and they'll do 8 divided by 2, and they'll put the 4 on top. Okay? If it's 2 and an 8, you're really reducing there. Or if you do want to treat it like division, put that answer on bottom. 5x is on top, 2x is on bottom. Kobe, they cancel. These 2 on bottom cancel out. And how many does it leave on top? 3. So you've got 4x to the third. Any questions about that? 8 divided by 2 is 4. X to the fifth divided by x squared is x to the third. This is distributive property. You have 3 things, and let me address something real quick. And I meant to, sorry, And so I meant to work those problems before we got started. But let me show you something. You had a problem on your homework similar to this, and we'll work in just a second. Problem on your homework similar to this, and this is so tempting. I understand, because if we flip-flopped it and you had 3 plus 6 root 2 divided by 3, you would distribute. You divide each of those by 3, right? And we want so bad to reduce this and to reduce this. You can't. It is highly illegal. If you have 2 terms on bottom, you can't just reduce it with a single term on top. Now, if it's flip-flopped, you can't for some reason. Okay? But this, instead of doing 3 over 3 and 3 over 6, you can't split it like that. Now, in the case of where we're working here, 6x to the third minus 9x squared plus 12x divided by 3x. Since there is a single term on bottom, you can split this. You can say 6x to the third divided by 3x. This is the distributive property. Minus 9x squared divided by 3x plus 12 divided by 3x. And just clean it up. Help me do that, Anna Marie. 6 divided by 3 on the first one is? Good. She had 3 x's, 1 x canceled out. She's left with 2 x's. Minus the second term, Trevor. 9 divided by 3, x squared divided by x. What does it give to you? 3 and x. Plus. Be careful on this one, Allie. 12 divided by 3 is 4. What about the x's? Doesn't cancel, right? So what are we going to do with it? You have 2 options. You can write this 4 over x, which is honest. There sure is. They can copy it down. There we go. Now, that changes things. X and x will cancel out, so mark it out. Thank you for that. Now, if it were the way that I wrote it, 12 over 3x, you had 2 options. You could leave that x on bottom and leave it positive, which I actually prefer, or you could have put it back on top if you wanted to and write it as x to the negative 1 power. Okay. Now, here's the fun part. And this is, I don't know, we might not do much today after this. Might give you a little bit more homework time. Synthetic division. And I'm not going to go into long division today. We don't use long division hardly any. I'm going to stick with synthetic division for now. We might talk about long division later on in the year. And I'm going to work this problem, long division, just to show you why I'm not going to go real deep into long division. Okay. Here, this is not distributive property. This is not your rules of exponents. This is division. X minus 5 divided into x squared minus 3x minus 9. And again, I said I'm going to work this long division just to show you what long division looks like. And then I'm going to come over here and work this another way, which is called synthetic division. Did y'all do synthetic division in algebra 2? Maybe. You'll recognize it if you did once we started. Okay. Long division. Think about back in 4th grade maybe. Horrible year because of long division. 32 into 68,967. And how sad is it that you learn all that long division stuff and then once you get older you never use it? Right? I'm thinking, honestly, probably within the next 10 years, they'll take long division out of elementary curriculum. Because calculators are so readily available. How many people divide 32 into that by hand? Doesn't happen much. But who knows? Okay, if you don't remember, let's go back and let's work a long division problem. 32 will not go into 6, so we move over and say 68. And here's always been my rule when I teach this. Let's worry about the first, and I'm saying all this for a reason, by the way. Let's just worry about the first number. Instead of saying 32 into 68, let's just say 3 into 6, and that'll kind of give us an estimate of about how many times it'll go. And 3 will go into 6 twice, so let's try 2. 32 will go into 68 possibly 2 times. What do we do with that 2? 2 times 32, which is 64. And we 68 minus 4 is 4. Subtract and bring down. Okay, that's enough of that for now. Let's go over here. We do the same stuff. Long division when you're dealing with polynomials now, a trinomial and a binomial, you work it the same way. To see about how many times it would go, instead of worrying about both numbers, let's just worry about the first number, or in this case, variable. And instead of x minus 5 into x squared minus 3x, let's just say x and x squared. I need to know how many times will x go into x squared. How many times will x go into x squared? Well, how do you do division? How many times will 2 go into 8? How do you know how many times 2 will go into 8? How do you know it's a 4? Because 2 times 4 is 8. Right? Do you actually divide in your mind? Ever thought about that? Probably not. Do you actually, if you're doing 8 divided by 2, do you sit there and picture 8 things and you break it down into 2 things and you can't? You don't do that. You don't divide in your head. How do you divide? You multiply. You say, okay, 8 divided by 2. 2 times what is 8? That's how, hopefully. And if you don't do it like that, please start. It's much faster. Let's see, 81 divided by 9. I've got to picture 81 dots. I've got to divide it into 9 groups. I mean, don't do it like that. 9 times 9 is 81, so it's 9. So let's remember how we divide, and we're going to do this the same way. X into x squared. We got to ask ourselves, x times what is x squared? And that would be in x. Correct? Same way you did it here. 32 into 68 goes 2 times. Now let's test it. How do I test it? I multiply, right? But you don't just multiply the 2 times the 3. You got to multiply it by both. X times x is x squared. X times negative 5 is negative 5x. Next, you subtract. And I'm going to put my minus sign in parentheses to remind me that this bottom thing is in parentheses. I'm subtracting both of these, not just one of them. I'm doing x squared minus x squared, and if you do it correctly, that should always cancel. Negative 3x minus negative 5x, that's negative 3x plus 5x, which is 2x. What do I do next? I bring down the next number, which in this case is minus 9. And I say again, here 32 will go into 49 how many times? Here I say x will go into 2x how many times? Jordan, how many times do you think x will go into 2x? Twice. Good job. How does she know that? Because when she multiplies it back out, 2 times x is 2x, and 2 times negative 5 is negative 10. We subtract. If you do it right, this should always cancel. And negative 9 minus negative 10 is 1. And I had so many people, and it kind of made me cry, last year that wanted to put a big R and put a 1 there. Not anymore, guys. That was nice in 3rd, 4th grade, but once we got to 5th and 6th grade, we learned, well, you can take that remainder and you can write it over what you're dividing by. Remember that day. So I'm going to do plus x minus 5. Nope, just kidding. Goodness. Plus 1 over x minus 5. The remainder over what you're dividing by. That's divided. So pretty much when you divide this by this, you get x plus 2, remainder 1. Okay, that takes a while. So we developed a shortcut called synthetic division. Now every once in a while you might have to use long division. If you're dividing by like x squared stuff, you have to use long division. But when you're dividing by a line, hopefully y'all know what I'm talking about. That's a line. That's a line with a slope of 1 and a y-intercept of negative 5. That's linear form, right? Y equals mx plus b. You're dividing a parabola by a line. And anytime you're dividing by something linear, like x plus 3, x minus 5, 2x plus 1, you can use what's called synthetic division. You have a box, you have a line. This is called synthetic division. What I'm about to show you, start in your notes. Make sure if there's nothing else you learn in chapter 1 that you learn how to do synthetic division. Because we're going to do synthetic division the rest of the year. Okay, here we go. Your first step. This is what you're dividing by. But we're not going to put the whole x minus 5 up here. You're going to put, okay, this is hard for me to explain. because we're not really into what I mean by zeros and factors and roots and all this stuff. So here's how I explain it. If you set this equal to 0 and solve it, that's what you would put in the box. If this is x minus 5, you'd put a positive 5. If this was x plus 3, you'd put a minus 3. I'm not just going to say put the opposite of this for this reason. What if you're dividing by 2x minus 1? Say, what's the opposite of 2x minus 1? If it's a single term here, minus 5 plus 6, yeah, you can just put the opposite in the box. But if you're dividing by 2x minus 1, set that equal to 0, move the 1 over, divide by 2, you would actually put a 1/2 in the box. Okay? We're not. We're dividing by x minus 5. Okay. Next to the box, you will put the numbers that are in front of your letters. You have 1x squared, you have negative 3x, and you have negative 9. Synthetic division. Okay, here's your steps. First step, your first number, bring it down below the line. It's going to be bring it down, multiply, combine, multiply, combine, multiply, combine, multiply, over and over and over and over. The number that's below the line, we will now multiply by the number in the box. 5 times 1 is 5, and we're going to write it below or negative 3. We're just going to keep working our way over. Negative 3 and a positive 5. When you combine those together, that's a plus 5. Negative 3 and positive 5 gives you 2. As the number is now below the line, we multiply it by the 5, and it gives us a 10. That's a positive 10. Again, negative 9 and a positive 10 gives me a positive 1. And I always write that last number in a box as well. Look at the answer that you got a while ago. 1x plus 2 with a remainder of 1. 1x plus 2 with a remainder of 1. A little faster, right? Yes. That's it. That's what I was about to say. The last number, and that's the reason I put it in the box, is always the r that you want to put. And it's going to be r over this. That's x minus 5. And here's how I do it. From that remainder, I start counting up. This is always my constant term. This will be like my plus 2, minus 3. It won't have any x's. The next number will have an x attached to it. The next number will have an x squared. The next number will have an x to the third. The next number, if you had one, will be x to the fourth, x to the fifth, x to the sixth, and so on and so forth. Okay, I'll work a few of these because they are so important. Something else about this problem, I'm glad I just thought about. Something else about this problem that might be even more important. Since you had a remainder, let's go back and revisit 3rd, 4th grade. Since you had a remainder, what does that say about this problem? 8 divided by 4, 9 divided by 4. This does not have a remainder. This does have a remainder. 8 divided by 4 is 2. 9 divided by 4 is 2 with 1 remainder, or 2 and 1/4. What does that tell us? 8 is a multiple of 4. 4 is a factor of 8. 4 is not a factor of 9. 9 is not a multiple of 4. So what does that tell us about this? X minus 5 is not a factor of x squared minus 3x minus 9. Why is it not a factor? Because it has a remainder. That's extremely important. Because what are we about to start? Factoring. And are we going to be factoring just x squared stuff now? No, we're going to be doing x to the third, x to the fourth, x to the fifth stuff. So we're going to have to use synthetic division for that. Next problem, another synthetic division. Can anybody tell me what goes in the box? You're dividing by x minus 2, so you put a positive 2. If you set it equal to 0, solve it, it would be a positive 2. Or since it's just a single x, not 2x, 3x, you just put the opposite of that. Okay. Don't jump ahead because you're fixing to mess up. 1x to the third. Looks like some stuff's missing there. Because usually it's x to the third, x to the second, x to the first, and then a number. You have to put the missing stuff. That's the number one rule. X to the first. This is x to the third. This is x to the second. There are none. There's no x squareds there. There's no x's there, but there is a minus 8. If you don't put those missing parts, and I forget that sometimes too. If you don't put those missing parts, it won't line up right. It won't come out. I sure will. See, x to the third minus 8. Normally it's like x to the third plus 4x squared minus 5x, to where it's got a third power, a second power, a first power, and then like plus 7 to where it's like a 0 power. It counts down. It's in what's called descending order. This one is in descending order, but there's no x squared there. There's no x term there, but there is a constant term. So that's the reason I put 0 and 0, to fill in for the x squareds and the x's that aren't there. And again, your step, bring it down, multiply, combine, multiply, combine, multiply, combine, multiply, combine, and just keep doing it till you run out of numbers. Bring it down, multiply by the 2. Combine those, gives you a 2. Multiply those, gives you a 4. Combine those, gives you a 4. Multiply those, gives you an 8. Combine those, gives you a 0. Awesome. You have 0 remainder. There's no leftover. Counting backwards from your remainder, this would be your constant term, so it would be like plus 4. There's no x's. The next number would be your 1x term, single x term, I should say. The next number would be your x squared term. If you had another one, it'd be like x to the third, x to the fourth, x to the fifth. You just count up. Um, 32 divided by 4 is 8. That's easier. And I told you a while ago, you divide by multiplying in your mind. You also subtract by adding. Try to subtract something. 8 minus 3. Do you actually take the 3 away, or do you do it backwards? That's just me out of curiosity. How do you do it? If I told you 8 minus 3, you've done it for so long, it's hard to think, right? It's just like, well, it's just 5. It just is. I actually add backwards. I say 3 plus what is 8. So I had a college professor that told me there's actually no such thing as subtraction. There's no such thing as division. It's all multiplication and division. And the reason I say that is to say this. 32 divided by 4 is 8. The reason we knew that is because that 4 times 8 is 32. Once you get that answer, you can rewrite it, right? I want to show you what you just did without realizing. X to the third minus 8. Since you divided by x minus 2 and it gave you this, does that not mean that you can multiply that to give you x to the third minus 8? Sure. Since x to the third minus 8 divided by x minus 2 gives you x squared plus 2x plus 4, that means that x to the third minus 8 is equal to x minus 2 times x squared plus 2x plus 4. What you just did was factor. And we're leading into factoring. We're not going to factor today. We'll start that probably tomorrow. But synthetic division is your first step to factoring cubes, fourth powers, fifth powers, sixth powers, and so on and so forth. Now, they kind of did you a favor by letting you have x minus 2 and kind of telling you, hey, try x minus 2. Try to divide by this. But you broke down an x to the third power into a line. Again, I'll call that a line all year. X to the third actually looks like this. That's what a cubic equation looks like. And we all know what a line looks like. Alright, I'm going to try it. There's x minus 2, and we all know what an x squared equation looks like. That's parabola. So, in essence, you kind of did this as well. A cubic equation is equal to a line times a parabola. Okay. Leave it alone. I believe that's factoring. Let's do, but like I said, I don't want to do factoring. Well,